This is Mark with your Advanced Assembly Technology Minute.
Hi, I'm Mark from Advanced Assembly, and I'm here with everything you wanted to know about solder. Modern electronics would not exist without flux and solder. Every integrated circuit, every passive component, every wire and every connector and every copper pad is cleaned with an acid called flux and attached to printed circuit boards with a carefully engineered combination of metals called solder. Eutectic describes a very interesting bit of physical chemistry. You see, as the temperature of a pure substance such as water increases, it will undergo phase transitions at specific temperatures and pressures. The entire body of the substance absorbs any heat delivered to it during the transition and uses all of the thermal energy to change the phase of the material while maintaining a constant temperature. But what happens if you don't have a pure substance? What if you are instead dealing with a carefully mixed alloy? That's when the really interesting things start to happen. In alloys, the discrete transition temperatures that exist between solid phase and liquid phase morph into transition temperature ranges as a new intermediate phase of matter appears that is part liquid and part solid. The transition temperature range depends on the ratio of substances in the mixture and how thoroughly the substances are mixed. As a solid phase alloy is heated, it begins to melt at a solidus temperature and is fully melted at the liquidus temperature. In between the solidus and liquidus temperature, the mixture is a combination of solids and liquids, A plus L, that can be thought of as a paste. If you've ever seen dirty snow in the wintertime, you've likely seen that intermediate phase of dirty water that stays a slush puddle over a range of temperatures. Binary phase diagrams often show the phases of lead-tin mixtures based on mass ratio and temperature. As you follow a line vertically up the diagram, you'll see that it does not pass directly from solid to liquid, but it crosses through a third phase. A very particular ratio of materials, the solidus and liquidus temperatures meet at the eutectic point. The slush paste phase completely disappears, and the alloy transitions directly from the solid phase to the liquid phase in an isothermal process. The eutectic temperature is a discrete transition temperature that is lower than the transition temperature of either substance in pure form. This is important for microelectronics because it reduces the exposure of integrated circuits to high temperatures.
If you liked this video, let us know by clicking the like button at the bottom of the screen. But don't stop watching now. We have other educational and informative videos on this channel. To learn more about what Advanced Assembly offers and how we can help you, please visit aapcb.com.